Rural India is real India, and it has the largest rural population in the world. About 69% of Indian population, that is 833 million people, live in villages. Rural India is undergoing a slow but sure transformation. Rural infrastructure, particularly rural roads, have transformed rural livelihoods by improving productivity and living conditions and reducing poverty. While it is encouraging that about 65% of the rural habitations are connected by all-weather roads, the remaining two need to be connected to make the picture complete. The challenges are many. India is distinguished for its geographical diversities, with mountains, hills, rivers, forest, wetlands, deserts and scattered habitations in remote areas. Also, there exists a wide range in the subgrade soil types, traffic pattern and availability of construction materials. Added to these were the conventional methods and specifications that invariably recommended intensive use of technology and material, resulting in higher cost of construction. To sum it up, a breakthrough was desperately needed. And the breakthrough has come in the form of many new products and technologies based on both site-specific conditions and cost effectiveness. The NRRDA, in collaboration with specialized agencies, has introduced these new techniques and technologies in Pradhan Mantri Gram Sadak Yojana. Many educational and technical institutions, along with a number of research centers, are constantly striving to introduce new, cost-effective and eco-friendly technologies for rural road construction. Some of the major new products and technologies are: use of fly ash in cement for concrete structures, roller compacted concrete pavement, cold mix technology using bitumen emulsions for bituminous wearing coat, use of waste plastic in bituminous works, use of blast furnace slag, cell-filled concrete technology. And the last, but certainly not the least, is the use of coir geotextiles in rural roads construction, a technology that stands out on account of its ecological compatibility and cost effectiveness. Slowly but surely, this path-breaking innovation is transforming the present and beckoning the future. A future of eco-friendly roads. India, mainly the coastal region of Kerala, produces 66% of the total world supply of coir fiber from the husk of coconut fruit. Thick, green clusters of tall, fruit-laden coconut trees give this land such a different and distinct identity. There are a number of production units, both public and private, across the state where the geotextiles are produced both manually and mechanically. This industry is conspicuous by the active participation of the women folk in each and every stage of production. And the abundance of locally available raw material has given an unprecedented boost to this long-lasting technology that offers multiple advantages.
Geosynthetics has proven to be very good material for improving the properties of the subgrade soil. And among the geotextiles also, geosynthetics also, coir geotextiles is one material which is having lot of potential. And if you take this geotextiles, we can have the natural geotextiles or artificial geotextiles. Artificial geotextiles, which are made from the polymers and all those things, they suffer from the problem due to UV rays. But in case of the natural geotextile, that problem is not there. And among the natural geotextiles, we have jute geotextiles and coir geotextiles. And jute, among these two again, coir geotextile, which is made from the coir fibers, is better because of the higher strength of the coir fiber compared to the jute fiber, and also the life of the coir fiber is more than that of the jute. This coir geotextile is made from the coir fiber, which is again an agriculture product. So, it is, we can say that it is a renewable one, and also the growing of the coconuts and all the things will bring more of livelihood for the farmers and all those people. So, if you encourage the use of the coir geotextile in the road construction, then it will have lot of indirect benefits, not only for the road construction, but other benefits also. Now, if you use the coir geotextile in road construction, it can be provided at anywhere in the structure of the pavement, but generally it is preferred to provide above the subgrade. And if it is provided above the subgrade, it will act as a reinforcing material. It will also act as a drainage material. So, it will perform many functions in addition to these two, and thus enhance the life of the pavement. Generally, we have a feeling that the coir geotextile is a biodegradable, and after some time the coir geotextile, once it degrades, it will not be available there. So, it may not perform the function what it is supposed to, but the life of the coir geotextile is more than 5 years. So, during this 5 years period, whatever has to happen in the pavement, that will happen, and the subgrade and other layers also will get strengthened. So, after that 5 years or 6 years period, even if the coir geotextile is not present, as it would have degraded, there will not be any problem. So, it will retain its strength as it is. That is it. So, by using the geotextile, we can reduce the total cost of the construction.
Coir geotextile technology stands out when its varied and various advantages are assessed individually. Coir geotextiles provide a physical separation layer between the aggregate and the subgrade soil to prevent migration of fines, and thus preserve the structural thickness of the aggregate by maintaining it clean. Coir geotextiles are recommended for this function because of the low cost, high coefficient of friction, high elongation 30%, and high coefficient of permeability, besides good drape to conform to the contour of the surface. The coir geotextiles provide an edge over the natural fiber geotextiles in providing good separation as well as adequate drainage by retaining soil particles and allowing water to flow across the plane due to the inherent porosity 40% of the fibers. Experimental studies have proved that while cotton and jute degrade within 6 months and 2 years respectively, coir geotextiles provide good support for about 5 years. It is resistant to saline water also. Let us now see how this technology is put to practical use. To begin with, the subgrade is prepared to the required compaction and camber. This initial stage is extremely important, holding the key to the desired end result.
After putting the optimum moisture and rolling to the 100% compaction, we have to check it again for whether it is being compacted to the 100%. So, for that the tests available is a sand replacement method either or core cutter method. So, here what we done is a sand replacement method. So, in that we will be digging a hole of a 10 centimeter dia and 10 centimeter depth, and whatever the soil we have taken inside from that hole, that will be taking the weight, and also we will be checking the moisture content of the soil, and we will be placing the sand pouring cylinder above that, and sand is poured into the hole, and again the volume what we are finding out the hole for checking the weight of the soil and the volume comparison to find out the density of the soil what we dug. So, that density will be compared with the original density, that is the maximum dry density we have tested from the lab. Then we will compare it, whether it is coming to the near or above, then that is good, other if it is coming below, that is poor compaction or less than 100%. So, once again we have to apply the watering, that is to be made the optimum moisture, again we have to re-roll. So, whatever we tested is exactly 100%. So, we are getting a good compaction over here, and it is ready for the subsequent layers, that is we are going to place the geotextile above that.
Clearing the subgrade is followed by rolling out the first roll of coir geotextile using one of the edges as reference. The second and third rolls are rolled out in the next stage, maintaining the required overlap. Special attention is paid to ensuring the removal of folds and wrinkles. The rolls are then fixed to the subgrade by using clamps after folding for a small length at the beginning and end of the roll. And also at the curves and slopes in order to avoid chances of movement. The geotextile needs to be folded properly, not for full width, to account for the difference in length along the two edges, inner and outer, of the road curves. Thereafter, each roll is tied at the overlaps using cable ties in the spacing of not less than 1 meter. The next stage is about the preparation of the sub-base. For this, the lorry tipper is brought to the tip of the geotextile and the material dumped over it. It can also be done manually. Any movement of construction equipment directly on the geotextile is to be very carefully and consciously avoided. The dumped material is then evenly spread either manually or mechanically by using the JCB to the designed thickness. Then the profiles are corrected manually for the required camber and super elevation. A roller is then used to roll the material to 100% compaction. After finishing the GSB layer, the shoulders are maintained with good gravel earth for spreading the grade 2 material as base layer, the width of which is 3.8 meters. This is dry rolled to the required compaction and the screening material is applied to fill in the pores. Water is sprinkled over and it is then re-rolled. The next stage is spreading the binder earth on the surface, which is water rolled as per specifications. With this process over, it is allowed to cure or dry for a few days before the commencement of next stage. The grade 3 layer is then spread in the same manner as grade 2. And the screening material is again applied to fill in the pores. But at this stage, instead of binder earth, slow-setting bitumen emulsion is applied as prime coat for bonding. Above this base layer, rapid-setting bitumen emulsion is applied as tack coat, followed by 20 mm thick premixed shipping carpet using natural rubber modified bitumen or NRMB or VG30 grade bitumen. Finally, a seat coat using the same bitumen is spread over to finalize the surface layer. The results of the multiple advantages of this path-breaking technology are there for everyone to see. Out of the many roads constructed using this useful and innovative technology is the one between Vazikadavu and Perambula in the Koduvalli block of Kozhikode district. In the same block and district, another road between Kakundu and Chavalpara heralds the success saga of this technology. Same goes for the impressively eye-catching road between Korothumukku and Vannathipoil. And this is just the beginning of many such roads ahead. Needless to say, this cost-competitive, eco-friendly solution is here to stay.